real-world quadratic equations. We're going to be covering topics under the standard 2.3c and 2.6a. We're also going to be covering topics under that study island lesson, real-world quadratic equations. So these are looking at word problems that deal with quadratic equations. So you might want to review our translating vocabulary that I go over in the video 1.1a, symbolizing problem solutions. I go over a whole slew of vocabulary that might be handy for you in this lesson if that's not something you're already familiar with. And as always, just remember study tips. Make sure you're taking really good notes so you have those to refer back to. And also just make sure that you can also pause and rewind if I go too fast. And you can even pause at the beginning of the question, work the question out, and then watch the videos. That way you can self-check yourself and get a gauge of how well you're doing. So I'm so glad that you're here today, and let's go ahead and look at some questions.
This question says the radius of a circular sign is decreased by 4 inches. If r represents the radius of the original sign, which equation represents the area in square inches of the smaller sign? So here it's talking about the area of a circle, which is, we know that formula is pi r squared. Well, it's saying it's taking the radius and decreasing it by 4 inches. So that means I'm going to have my radius here, and it's going to be decreased by 4 inches, but everything else in the formula is going to stay the same. And so that's basically your new formula, only our choices here want it in standard form or closer to it. So I'm actually going to FOIL out this r minus 4 squared. And this is the trickiest part because some people want to just square the r, square the 4, and call it good. But this is actually saying take r minus 4 times itself, and it's actually a FOIL problem. So I'm going to have to take r times r, which is r squared, and then r minus 4 is a minus 4r, and then negative 4 times r is negative 4r, and then the last piece, negative 4 times negative 4 is a plus 16. And I go ahead and combine like terms. Negative 4r minus 4r is negative 8r plus 16. And so that's my new equation. And here we had the pi at the beginning, they have the pi at the end, it doesn't matter. And that means my final answer here is going to be A. Right, this problem reads, Felix the chemist performed this same experiment multiple times using a different amount of reactant each time. The table shows the amount of reactant he used and the amount of product he obtained from 5 different runs of his experiment. Which equation below represents Felix's results, where P is the amount of product and R is the amount of reactant? So here's our table with the top is our R numbers and P is on numbers are on the bottom. And so the easiest way to do this is to see if which one of these is when I plug in 0.5 for R, gives me 0.275 for P. And then it does, that equation holds true for each column here. So just go ahead and grab a calculator for this one. And take 2.7 times, and my first R number there is 0.5. So I'm going to put that in parentheses and square it, minus 0.4, and then press equals. And so when I first do that first R number, I get that 0.275 as my answer, which is what I need to get. So then I'm going to check it again with the 1. So I'm going to clear it and take 0.27 parenthesis 1 and parenthesis squared minus 0.4. And that gives us 2. So that's going to give me my answer of 2.3. That's what I'm looking for here. And if I were then you would want to go ahead and substitute in 1.5 the same way, and letter A is going to give you that P number that you need. Then you want to substitute in the 2 the same way, and then that's going to give you your P number that you need also for letter A, and then letter A also holds true for the last column too. And so that's how you know for sure that letter A is your answer, is that you've checked each column. And now I want to go ahead and show you letter B so that you can see an answer that works, that is wrong also. So I'm going to substitute in 2.7 parenthesis 0.5, that's my first R number, and that is squared in letter B, and then minus 1.35 parenthesis to substitute in that 0.5 again, and then plus 0.4, and this time when I press equals, it gives me a 0.4, which is not what I need here, and the P, I need a 0.275, so B could not be my answer. So here, as a waitress, Barbara usually takes 5 to 9 tables at a time during her shift. She found that when she is assigned 5 tables, she averages $15 in tips per table per shift. If she is assigned more tables, the amount of attention she gives to each table decreases. Therefore, she averages less in tips per table. For each additional table over 5 labeled as X, Barbara brings in $2 less in tips per table. Which of the following equation shows the amount of money she could make in tips if she takes 5 plus X tables? Alright, so here we have to think about how she calculates her nightly income. So her nightly income is the number of tables times the amount of tips she gets from each table. So the problem already tells us that the number of tables she takes on is 5 plus X. So then we just need to find out how could we write algebraically the amount of tip that she takes per table, the average of that. So we know that she starts at 15, but then for every table she takes on, it goes down $2 more. So she starts at 15, and then for every extra table, it goes down $2 more. So that means I'm going to subtract a 2 times X, 2 times the amount of extra tables to get that tip. And so now I have this represented algebraically, so I'm just going to FOIL out the problem in order to get my final answer. So 5 times 15 is 75. 5 times a minus 2x is minus 10x. X times 15 is a plus 15x. And then x times a minus 2x is a minus 2x squared. And so now I'm just going to rewrite this in a standard form and combine like terms. So standard form, I put my highest exponent first, so minus 2x. And then my next is just the plain x. So I'm going to combine those like terms. Negative 10x plus 15 is a plus 5x. And then my constant at the end is a plus 75. And that's going to be my final answer, which is A. So here they want us to write an equation and then actually solve for it. This problem says Phil hit 15 more home runs than Charlie did last season. The product of their home runs from last season is 250. How many home runs did Charlie hit last season? So first let's write down algebraically what we can pull from the problem. We know that Phil hit 15 more home runs than Charlie last season. So that can be written as P equals 15 plus C. We know that the product of their home runs is 250. So that means if I take Phil times Charlie, that's going to equal 250. Well, I know that Phil can also be written as that 15 plus C. And then I can take that times the c, and that equals 250. And now I can actually solve this equation because there's only one variable in it. This just has c's in it. So it's a quadratic equation, so that means I'm going to have to go ahead and we'll do this multiplication here first. So c times c is c squared, and then c times 15 is 15c. And so in order to solve a quadratic, I'm going to have to set this equal to 0. So I'm going to have c squared plus 15c, and then when I bring that 250 over, I subtract it from both sides, and that's going to equal 0. And so now to solve this quadratic, you could use quadratic formula, you could use factoring. I'm going to go ahead and use factoring. And this factors into c plus 25 and c minus 10. And then in order to solve for c, I had to set each of these parts equal to 0 by itself. And when I solve each of these equations, I get c equals negative 25 and c equals positive 10. Well, the question is, how many home runs did Charlie hit last season? He can't hit negative 25 home runs. That answer doesn't make sense, so I can't use it in my real world equation here. Now, he can hit 10 home runs. That makes sense. So my answer here is going to be D. This question says the path of a projectile can be modeled by the function below, where t is the time in seconds and ht is the height in feet. Which of the following could be the approximate time when the height is 150 feet? So if I look at this is an upside down frown parabola, which makes sense because if you're throwing something, it's going to go up for a while and then come back down. So it wants to know at what time is this projectile at 150 feet. So that means that my height is 150 and I'm going to be solving for t. So I'm going to set this equation up and I'm going to have 150 equals negative 8t squared plus 48t plus 100. So all I did was substitute in 150 for the height. And so now what I'm going to do is solve this quadratic equation. So my first step is to set this equal to 0. And I have a negative t squared here. And when I solve quadratics, I like my t squared coefficient to be positive. So that means I'm going to bring everything over to the left. So I'm going to be adding 8t squared to both sides. I don't have a t squared on the left, so I'm just going to write it off in space. And then I'm going to subtract 48t from both sides. I don't have a like term there to combine it with. And then I'm going to subtract 100 from both sides, which I can combine with that 150 to get 50. So when I have my positive 8t squared minus 48t plus 50 equals 0 when I'm done moving everything around. And now I'm looking at my answers here, and not all of them are whole numbers. So there's a potential that this doesn't factor. So I'm just going to go ahead and use the quadratic equation right away, which is over here, is x equals opposite of b plus or minus the square root of b squared minus 4ac all over 2a. And so here, my a number is 8, my b number is negative 48, and my c number is 50. So I'm going to use those three numbers to substitute into the quadratic formula. So when I do that, it's going to look like this after I substitute into the formula. And so then I just have to work it out. So negative 48 squared is 2,304, and then 4 times 8 times 50 is 1,600, and then 2 times 8 is 16. Next, I'm going to go ahead and do the subtraction underneath the square root. And when I do that, I get 704, and then I'm going to find the actual square root of 704, which is going to be a decimal, and so I'm going to take that decimal to 2 decimal places, and that gives me 26.53. And so now I have to do the plus version of this problem and the minus version of this problem. So I'm going to take 48 plus 26.53, and that gives me 74.53 over 16. And then when I do that division, I get 4.66 seconds. And then I have to do the same thing for the subtraction. So I'm going to take 48 minus 26.53 divided by 16. And so when I subtract, I get 21.47 divided by 16. And when I do that division, I get 1.34 seconds. And so here it's saying that it's going to be at 150 feet at 4.66 seconds and 1.34 seconds. And so both of these are right answers. One is just on the way up and the other one's on the way down, but they only give me letter B, the 1.34 seconds, so that's going to be my final answer. Here, this question says, Nancy is playing kickball. The ball's height in feet can be represented by the equation below. What is the approximate maximum height the ball reaches? Well, here it wants to know a maximum. It wants to know what's the vertex of this ball's path. So to find a maximum, we're going to use that x equals negative b over 2a. Only here, instead of x, I'm going to have t. So that's how I'm going to find the time that it takes to get to the maximum. But here it wants feet, so it means I'm going to have to take it one step further and substitute that back in. So one step at a time, though. Here, my b number is 10, so the opposite of 10 is negative 10. All over 2, and my a number is negative 16, the coefficient in front of t squared. And so I'm going to have negative 10 over negative 32. And so when I actually do that division, the time it takes to get to the maximum is 0.31. So now I'm just going to have to substitute that time into the equation to get my height. So I'm going to have negative 16 times 0.31 squared plus 10 times 0.31. And then I'm just going to have to work that out in order to find the height. And when you can plug that all into the calculator or work it out step by step. But when you do that, you should get a final answer that's rounded to 1.6. And so that is the maximum height that my ball is going to reach, which is letter A. This question says the equation for the height t of a certain launched object is the h of t equals negative 4.9 t squared plus 9.3 t plus 25.4. The time t is the number of seconds after launch, and the height is in meters. Based on the information, what was the initial height at which the object was launched? So when you're at the initial height, that's the beginning height. No time has passed at that point. So when you're asking for the initial height, you're asking for what is the height when time is 0 seconds. So that just means to find the height, I'm going to substitute 0 in for the t. And so working with 0 is pretty darn exciting because when you multiply something by 0, it's just automatically 0. So these first two terms are just going to become 0. So I'm going to have 0 plus 0 plus 25.4, which is just 25.4. So that means my initial height is 25.4 meters, which is B. Thank you for joining us today, and I hope you learned something new.